Back in lesson 3.1 of this academy, we covered why some 6-gauge wire can only handle 75 amps, while other 6-gauge wire can actually handle 120 amps. But did you know that wire rated for 120 amps may only be able to handle 40 amps depending on where and how it's installed? Clearing up the confusion on the max amps a wire can carry is exactly what I'm going to teach you here in lesson number 4 of this Wire Basics playlist. My name is Nate, and welcome to the EXPLORIST.life Mobile, Marine, and Off-Grid Electrical Academy. Now, before we get started, I put some important information about this academy, some additional resources, and some prerequisite information related to this video down in the pinned comment below. So be sure to scroll down and check it out. Now, as a disclaimer, this is an intermediate level topic, and if you're a true beginner to these concepts, this one's going to push you a bit. But just know that it's still important to have an idea of what I'm teaching you, but just know that you don't need to know this stuff like the back of your hand to install an electrical system, as long as you're using a good and solid pre-designed plan and wiring kit like you'll find in our shop. Let's get started. How many amps can a wire handle? Back in lesson 3.1 of this academy, I taught you that the amps a wire can handle is greatly affected by its insulation temperature rating. And Table 4A of the American Boat and Yacht Council Standard E11 summarizes the various allowable ampacities of wire based on its wire size, the temperature of its insulation, and whether the wire is installed in a hot engine compartment or not. And on this chart, we can see that 6-gauge wire with 105-degree insulation is rated for 120 amps when installed outside of an engine space, but only 102 amps when installed inside of an engine space. This is because the heat created by pushing a wire to its max has to go somewhere in order for the insulation to not just melt. And if the wire is installed in a hot location, that heat doesn't really have anywhere to go. Now, if we go to Table 4B, the ampacities change. This table shows the max ampacity when the wires are bundled together in a sheath or in conduit. So, for more than one 6-gauge wire with 105-degree insulation, our allowable ampacity drops fairly dramatically down to 84 and 71 amps, depending on if the wire is installed in an engine space or not. Now, as an example, for our 50-amp Orion XS DC-to-DC charging retrofit kits, we allow use of 6-gauge wire as it would still be within spec with the 71 amps within an engine space. Although if you're looking to add another Orion XS in parallel, you would be pulling 100 amps, which would be over the rating for the 6-gauge wire, which is why you can see in our dual Orion XS wiring kits why we have upgraded the wire size to 2-gauge, allowing for 125 amps. Now, these derating factors are the lowest that a DC circuit wire gets derated. Now, tables 4C through 4E show the allowable ampacities of wires in AC circuits when 4 to 6 wires are in a bundle, 7 to 24 wires are in a bundle, or 25 or more wires are in a bundle. Now, an example of bundling in a camper van can actually be seen right from the factory in the Ford Transit, where the wires that run down the top of the driver's side, that has about 20 or so wires tightly taped. The engineers at Ford likely accounted for bundling when sizing these wires. Wires that aren't taped, zip-tied, in conduit, or otherwise tightly bound are not considered to be bundled. Some real-world advice. Now, based on designing all of the systems you can find in our store at shop.explorist.life, I've noticed that in most applications, we actually hit voltage drop problems long before we hit ampacity limits of the wire when in a bundle and when using wire with 105-degree insulation. For example, using the EXPLORIST.life wire sizing calculator, we can see that 6-gauge flowing 120 amps at 12 volts with 3% allowable voltage drop is only good up to 7 feet, which is only 3.5 feet of positive and 3.5 feet of negative. Now, that's pretty short and a pretty specific use case and would realistically only be like the length of wire from, say, a Lynx distributor to a solar charge controller, which would be mounted right next to each other. So in my experience, there is really only a small use case where the derating factors of DC wires actually matter, but since you've been educated on what to check for, now you can move forward and make your own decisions here. Wire ampacities of AC circuits. For AC wiring, there is actually a rule of thumb, which is for 15 amp circuits, like lighting circuits, use 14 gauge wire. For 20 amp circuits, like standard outlet circuits, use 12 gauge wire. For 30 amp circuits, like higher powered appliances like welders, dryers, or RV hookups, use 10 gauge wire. And for 50 amp circuits like stoves, hot tubs, or 50 amp RV hookups, use 6 gauge wired. But those ratings must be checked against the derating tables as well, if the wires are zip tied into a bundle. But these rules of thumb hold true according to tables 4C and 4D, which allow for 14, 12, and 10 gauge wire to allow for 17.5, 22.5, and 30 amps respectively. If more than 24 current carrying conductors are used, like shown in Table 4E, the wires must be upsized because the derating factors have lowered the ampacity of the wire to below this rule of thumb. How many amps can Romex handle? While we don't recommend using Romex in mobile or marine settings, as you learned in our previous video, 3.01, I wanted to touch on what to take into account for how many amps Romex can handle, because it's still an appropriate wire to use in stationary applications like an off-grid cabin. Now, the same concepts apply here, but with solid core wire like Romex, we're going to be more appropriately looking at the National Electric Code instead of the ABYC. The NEC has its own derating tables, which Table 310.16 has a base ampacity for 90-degree wire like Romex of 30 and 40 amps for 12 and 10 gauge respectively. Table 310.15C1 shows the bundled derating factors based on the numbers of current carrying conductors in the bundle. So if we're trying to use that rule of thumb from earlier, as long as we stay below 6 current carrying conductors in our bundle, we're good to go. Now, 3 things to note here. Bundled wires refers to cables or conductors that are tied, wrapped, taped, or otherwise periodically bound together. Bundled wires also only refers to wires that are tied together or in contact with one another in a closely packed configuration for at least 40 inches. The ABYC defines bundled wires as single conductors or multi-conductor cables bundled for a distance greater than 24 inches. Lastly, regarding derating factors of the NEC versus ABYC. Now, we've already talked about the ABYC having their temperature derating factors based on if the wire is to be installed inside of or outside of an engine space. Now, the NEC also has temperature derating factors, but they are much more complicated and specific than ABYC, and you can see those derating factors in NEC Table 310.15B11, where they give a 10-degree range with an associated derating factor for each range. These ranges are there because, unlike in boats, yachts, and RVs, stationary installation temperatures stay pretty predictable for the most part, but only in the area of which the building is being built in. For example, the attic of our house here in the mountains of northwestern Colorado will never see the attic temperatures of an attic in Phoenix, Arizona, and an Arizona installation may have to use a little bigger wire because of that. Now, I hope this helps clear up why wire rated for 120 amps may be able to only handle 40 amps depending on where and how it's installed, as well as give you some insight into why certain applications may need larger or smaller wires. Now, it is worth mentioning that the system kits and diagrams that we sell in our store over at shop.explorist.life have all of the proper wire sizes included or figured out for you. Now, if the thought of messing up wire sizes scares you away from your next electrical project, we do offer installation services, and I'll put a link to our store and our installation services below. Now, we're going to be referring back to wire sizes throughout the rest of this academy, so be sure to bookmark this video for future reference and come back to it if you need a refresher. Now, in the next lesson, we're going to dial it back a bit on the tables and tech talk and share some real-life wire choice mistakes that we've seen so that you don't make the same mistakes. So click up here to watch, and I'll see you over there.